Next question. In the combustion reaction, if 0.5, a half a mole of C20H42 are consumed, how many grams of carbon dioxide would be produced? And it tells us that 1 mole of carbon dioxide weighs 44 grams. So it's telling us with this reaction, it's like an equation, and it's telling us for every 2 of these, that's the icosane, for every 2 of these, we produce 40 molecules of CO2. And a mole, I remember I told you before, I tell you what that is. A mole is 6.022 times 10 to the 23rd molecules. So it's a whole lot of molecules. But you don't have to memorize that number. All you have to know is that a mole is a basket or a quantity. And for every 2 molecules or moles or baskets of this icosane stuff, we're going to combine that with 61 baskets of O2, and we're going to get 40 baskets of CO2, carbon dioxide, and 42 baskets of water. And it doesn't matter really what size the basket is, as long as all the baskets are the same in terms of molecules, we should be good. So in this case, we're dealing with a half a mole of this stuff here. That's the paraffin, that's the icosane. So we're dealing with half a mole. And so on this side of the equation, half a mole is 1/4 of this. So we can get to half a mole by dividing this whole side by 4, and we get to half a mole. But then we have to divide the other side by 4 to make it in balance. So we're dividing the other side by 4, and we get 10. So for every half a basket of C20H42, we get 10 baskets of CO2. So we're going to have 10 moles of CO2, but the question is how many grams of CO2? They're asking about mass, they're not asking about moles. So we know that 1 mole is 44 grams. 1 mole is 44 grams, and we know that with a half a mole of paraffin, we just produced 10 moles of CO2. So if 1 mole is 44 grams, we can multiply that by 10, and we get 440 grams of CO2. That's our answer.